Hello everyone, welcome to another SuncatByte. In today's SuncatByte, we're going to cover variables. But before we do that, I want to cover one piece of information that we didn't cover during our last lecture about style, keywords, and programming format, general program format. And the thing that I want to cover is white space. So the main thing that we need to understand in C++ is that white space characters are flexible. What does this mean? It means that spaces, carriage returns, line feeds, tabs, vertical tabs, any kind of white space you can think of, form feeds, etc. Those are all white space. It means that those things are mostly ignored by the compiler. So the compiler mostly ignores white space, which allows for a lot of different formats or formatting of your code. Example of this, if I have cout, this is a test. Something like this in C++, that will be exactly the same as something like this. So these two pieces of code, this line here and this line here, exactly the same because C++ mostly ignores white space. So just wanted to give you an example of that. We'll look at an example at the end of this SuncatByte of source code or an actual program to look at this and illustrate it. But for now, just keep this in mind and we'll look at it again later. Okay, now on to the meat of this SuncatByte, which is going to be talking about variables. And when we talk about variables, we have to talk about a data type. So a data type is a type of container that can hold specific types of program data. Okay, one thing to keep in mind is that you must specify the type for each data item. So in C++, the types that we have would be something like char, float, int, double. We've seen some of these to this point in previous SuncatBytes: void, bool, wchar. We've seen an int, for instance, to this point. So the data type is the container. If the data type is the container, then the variable is the container's name or label. Okay, so you have the data type, which is the container, and you have the variable, which is the container's name. Each piece of program data has to have both. You have to have the data type and the variable. Data that's placed in the variable is referred to as the variable value. Okay, and C++ uses modifiers to create many more data types or specialized containers. And those modifiers would be short, long, unsigned. Those are examples of the modifiers. So how do we declare a variable? In general, variable declaration has to have the two pieces of information that we just talked about, a data type and a variable name. So the basic format is data type and then variable name. So for instance, say we're looking at a banking program, there are some variables we might need in a banking program. Banks are going to be concerned about a lot of things, but one might be the balance, float balance. This float is your data type, variable name is your balance. Another one would be deposit. Maybe the number of transactions that we've had, or transaction count. Maybe I'd want to know about a check number, an int that's a check number. Again, data type. Data type here is float. Variable name is balance. Data type is float. Variable name is deposit. Data type int. Name is transaction count. Data type is int here. Name is check number. So these are just some of them. Another one might be grade. Maybe there's a grade to the account. Okay. So you can also, when you create these things, there's some flexibility, and you can actually assign a value to them immediately. So in order to assign a value, you would use the equal sign, which is the assignment operator. So say we had another one of these variables called, or if we have check number, int check number. If we want to assign an initial value to that, we can say int check number 1. So now that variable will actually have the value of 1. All right. Here's some other statements. For declaring variables. So we talked about just a regular declaration here. Here we have, move this up. Actually, let's go to another page. There we go. We have average there for float. That is just declaring the variable. It does not have an assignment. Here we have another one called num for assigning a value to 5 to it. Here we have av. Equals 35.29, or 39 works. In this case, we declared the variable av, but it did not have a value. Here, we are actually assigning the value of 36.39 to it. Here, we declared the variable num, and it gets a value immediately of 5. If we want to declare two variables of type double at once, we can do it this way. Double money, comma, speed. So this creates two variables with the data type double. The names are money here and speed here. We can then assign them in this manner. Money equals speed 0.0. When you do this, these assignment operators, which we'll get into in another SuncatByte, but I want to go over a little bit right now, works from right to left. So we have 0.0 that gets assigned, this is the assignment operator, to speed, which then gets assigned to money. Okay, so that's a quick introduction to variables, declaring variables. A variable has an identifier. It's the name of a user-defined object, and you can also, an identifier will also work for a function, a class, or a label. So it's just the name of a user-defined object. For right now, we're just talking about variables. There's a number of rules that apply to identifiers, or naming, in this case, naming variables. Okay, so the names may contain letters, A to Z, and A to Z, so upper and lowercase letters, numbers, 0 to 9, or any combination of these things, or underscores. So the underscore. The first character must be a letter or a number. Sorry, letter or an underscore. not a number. First character has to be a letter and underscore. It cannot be a number. Names cannot contain any symbols, such as the tilde, exclamation point, at, pound, $, percent. Remember, that's a pound, not a hashtag. We're programmers. They're pounds, not hashtags. Ampersand, star, open close bracket, minus, quote, plus, equal, /. So it can't contain these, nor can they have spaces. Okay. In our one of our previous SuncatBytes, we talked about keywords. Keywords cannot be used in variable names. They're keywords. They're reserved for their intended purpose as a keyword. And they can be any length. Only 1024 characters are significant. Really, only 1024 characters matter. For the purposes of this class, you will not be getting that, having identifiers that long. If you do, we're going to be talking. But yeah, typically you're not going to get to 1024 characters for a variable name. Okay, and then identifiers can be inside a function, outside a function, and in a function header. We'll get into these specifics later. For now, we've only talked about one function. You may know what that is already. What do you think that function is? If you said the main function, that's right. That's the function that we've been working with so far. So the variables identifier, and the variables can be outside a function and in a function header line. The place, the location of the declaration determines or dictates what parts of the program can see and have access to the variable. This access is known as the scope, and we'll talk about this in more detail later in the term. And the last thing, if you try to use a variable before it has been declared, it will not work. You'll get a compiler error. So variable must be declared before using it, or before it is used. All right, so these are some important things about variables, the naming conventions, how we declare them, how we initialize them, assign values to them. All very important things, all things you will need for your first program, for program 1 in this course. So let's go ahead and jump over to the example and go back to the white space that we talked about at the beginning of the SuncatByte. What we want to do for this is look at this sample program, which is may look familiar to you. It's Hello World, but it's Hello World in one line. So as you see, we have a comment at the top that tells us exactly that. This is our hello program written in one line. We have IOStream included using our standard namespace, and then hello world completely written in one line. If you think back to our style example in our earlier SuncatByte, this isn't exactly the best style, right? But it works because of the white space and C++ not really being really flexible to white space. So we can compile this, we can build the solution, we can debug it, and we get hello world. Interesting thing that we see here at the top, notice that what this basically is a permission issue on my Mac. So if you're seeing this error message when you run programs, the programs will still execute, but it means that you're running them out of a directory that you don't have permission to write to, more than likely. So move them to the desktop or somewhere else where you have the ability to write to the directory. But anyway, you notice we do get hello world here. So it still executes, you just get that message at the top. Now, I could take this and put it in a format that we would consider to be a better style, right? Very easily by hitting return a few times. Now we have it back to how we would expect to see it, maybe even put the return statement on its own. We can then build this again, run it again, and there you go. It runs exactly the same as the other. Let's see here. So just in case you guys want to figure out how we could get rid of that error message, say we open folder and file Explorer. See, I'm actually running this from Google Drive, which I don't have permission to write to remotely. So that's why this is giving me this error message. So I can save this project. I can close it. I can come here where it's written, and since we're in this in this mode, let's go ahead and do what we usually do: is we delete the debug folder, or database file. We can delete our debug. I don't know why this has a backup, but we'll get rid of that too. Come here, and we'll delete this debug folder. Okay, and we'll come back here. We'll send this guy to compressed zip folder, and I'll move this. I'll copy it, and I will move it to a place that I know I have the ability to write to. So on this particular machine, that will be here. For you, well, you can just move it to your desktop. Oh, look, we already had one here. Delete this. So then if I now extract it, and open the solution file, this should open shortly. I can build this project again. I can run it, and notice I don't have that error message because I can write to this file. So just a little tip for you guys. Well, that'll be it for this Suncat Byte. If you have any questions, as always, please email me or post in the discussion board forum, or jump on one of our live sessions for office hours on Tuesday or open lab hours on Thursday. Until then, take care, and I will talk to you soon.